Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Hello, lesson 30. Hello, trigonometry and the Pythagorean theorem. Classwork exercise 1-2. Exercise means you try it, pause the video, see if you can do these, come back, and we'll take a look. All right, it says in a right triangle with an acute angle of measure theta, sine theta is 1/2. What is the value of the cosine of theta? Draw a diagram as part of your response. So we need to draw a diagram. So it's a right triangle. So there's my diagram. It's not drawn to scale, keep in mind. And it says in a right triangle. So yes, this is the right angle with an acute angle of measure theta. So I'll put theta down here. Sine of theta is 1/2. Well, sine, remember, is opposite. Sine is opposite over hypotenuse. So the opposite is 1. This is my opposite side. And the hypotenuse is 2. So there is what we were given. A triangle with a measure of angle theta with a sine of 1/2. What is the value of cosine theta? In other words, I need to know what this side is. Draw a diagram as part of your response. Okay. Well, if I use the Pythagorean theorem, then I can say that this is A, this is B, and this is C. So if I said A squared plus B squared equals C squared, and A is 1, and I don't know B, and my hypotenuse is 2, then I get this. And then simplifying, I get 1 plus B squared equals 4. Subtract 1 from both sides, and I get B squared equals 3. Take the square root of both sides, and I get B equals the square root of 3. So that would make this side the square root of 3. So the cosine, to answer this question, the cosine of theta equals adjacent over hypotenuse. Okay, so if you haven't done 2 yet, pause it, see if you can do what I just did here in 1, and see if you get the right answer. So again, in this right triangle with an acute angle of measure theta, sine theta equals 7/9. What's the value of tan theta? Be careful. Draw a diagram as part of your response. Okay, so I'm going to draw another diagram, or actually I'll just, for time reasons, I'll bring this down here. And so now we are talking about an angle theta where the sine is 7/9, opposite over hypotenuse. I need to find this side. A squared plus B squared equals C squared. 7 squared plus B squared equals 9 squared. 49 plus B squared equals 81. Subtract 49 from both sides, and that would be 32. So B equals the square root of 32. Off to the side here, I want to see if I can simplify 32 with my factor tree. 32 is 2 times 16. 16 is 2 times 8. 8 is 2 times 4, and 4 is 2 times 2. And I look for pairs. There's 1 and there's 1. Multiply, so each pair gives us 1 outside, and multiply them. 2 times 2 is 4. So B equals 4, and then my remainder of a single value stays under the radical. So 4 square root 2 is the same as 32, because 4 squared is 16, 16 times 2 is 32. All right, so this side is 4 square root 2. Now let's answer the question. What is the value of tan theta? So I would say the tangent of theta equals opposite over adjacent. Okay? And I don't like having irrational denominators, so I'm going to rationalize it by multiplying by the square root of 2 over the square root of 2. And that would give me the tan of theta equals 7 times the square root of 2 is my numerator, which is 7 root 2. And then root 2 times root 2 is 2, and 2 times this 4 outside would give me 8. So the tangent theta is 7 root 2 divided by 8. All right, example 1. If this says, what common right triangle was probably modeled in the construction of the triangle in figure 2? Use sine of 53 equals 0.8 as an value. So they're approximating the sine of 53. So sometimes they give you that. They will tell you what they want you to approximate sine as, because if I turn my calculator on and I take the sine of 53, it's going to be 0.798635551, and it goes on forever and ever and ever because it's irrational. And they're just saying round it to 1/10, 0.8. Okay, so they're talking about the right triangle here. So let me highlight that, because sometimes students have trouble visualizing something three-dimensional. So picture a square tent, if you will. And the zippered door is here, and you open the zipper up, and there is a pole right in the center holding this tent up. So this would be a straight line from the door to the center of the tent. And then this is the pole holding the tent up. And then this is the edge. Okay, it's called a lateral surface of the tent, if you will. And there is a right triangle. Now, it doesn't look like a right angle there because we're looking at it from a different angle. But if we rotated it, then we would have a triangle that looks like this. Okay, and of course it's the other way around, so let me flip it. Okay, so picture this as my 53-degree angle is here. So now I've walked around to this side of the tent and I'm looking at it, and it's the screen side so I can see in. This is what I would see. This is the pole holding the tent up. This is the edge of the tent. And this is the floor from the zipper to the center. Okay, so I'm looking at it from this way. So I'm standing right here looking at it from this angle. So this is what the triangle looks like. And this is 53 degrees. And it says the sine of 53 degrees is 8/10. Did you hear what I just said? 8/10. Make that a decimal. So the sine of 53 degrees equals 8/10. 0.8 is 8/10. So that means the opposite side is 8 because we're dealing with sine, and the hypotenuse is 10. Okay. And then I can do the Pythagorean theorem to find the bottom. What common triangle was probably modeled here? Well, we have what are called 3, 4, 5 right triangles. 3 squared is 9, 4 squared is 16, 5 squared is 25. 9 plus 16 is 25. If I double those, if I multiply these sides by 2 and distribute, I get 6. I get 4 times 2, which is 8. And I get 2 times 5, which is 10. Well, I have 8, I have 10 here, so this must be 6. I could do the Pythagorean theorem and check that, but I'm not going to. 6 squared is 36, 8 squared is 64, 36 plus 64 is 100, and 10 squared is 100. So the answer to this problem is 6, 8, 10, special right triangle. So that is what the question was asking. Okay, page 2 brings us to part B. The actual angle between the base and the lateral faces of the pyramid is actually closer to 52 degrees. Considering the age of the pyramid, what could account for the difference between the angle measure in part A and the actual measure? Okay, so now let's go back to this. So now they're saying this angle measure, this is actually an old ancient pyramid, and the angle used to be 53, but now it's more like 52. What could be the reason for that? All right, so the Great Pyramid is approximately 4,500 years old, and the weight of each block is several tons. It is conceivable that over time, the great weight of the blocks caused the pyramid to settle and shift the lateral faces enough so that an angle is closer to 52 than 53 degrees. Part C says, why do you think the architects chose to use a 3, 4, 5 as a model for this triangle? Okay, so it says answers may vary. Of course they would vary. People have different opinions, but that says perhaps they used it, one, because it is a right triangle with the shortest whole number side lengths to satisfy the converse of the Pythagorean theorem, and two, because of the aesthetic it offers. So when I was years and years ago, when I was in college, I had to read a book about Pythagoras. He's a Greek philosopher from the island of Samos in Greece. And there are all kinds of books here about him. So I highly recommend if you want to read more about this pretty interesting dude. Okay, so that would also possibly give you some solutions as to why they used the 3, 4, 5 right triangle way back 4,500 years ago. Okay, example 2, it says to show y tangent of theta equals sine theta divided by cosine theta. Well, let's start out by listing these things. So what is the sine of theta in this triangle? Sine of theta, here's theta right here. Sine is opposite over hypotenuse. So sine of theta in this case would be A over C. Cosine of theta is adjacent over hypotenuse, which is B over C. And tangent of theta equals opposite A over adjacent B, A over B. Okay, so here are our 3 trig ratios. And then we would say, well, let's see, why does tan theta equal sine theta divided by cosine theta? That is the question. Okay. Well, sine theta is right here, and cosine theta is right here. All right. So tan theta equals sine theta over cosine theta. Because tangent, if sine theta is over cosine theta, I can rewrite this as this. Well, what is sine of theta? Sine of theta is A over C divided by cosine of theta, which is B over C. And remember back in algebra, when we have a fraction divided by a fraction, we can multiply by the denominator's reciprocal. So this would be the same as the tangent of theta, and it would be AC times, and then you flip this, CB, the C's cancel, and then we get tan theta equals A over B, which is right here. So that is why the tangent of theta equals sine theta over cosine theta, just working in the reverse direction. Starting with this, we can get to here. So therefore, tan theta is the sine theta divided by the cosine of theta. Okay, before I go any further though, I do want to mention something else. So if this is cosine theta over here, and this is the sine of theta over here, sine's opposite, cosine's adjacent, and this is the hypotenuse. Okay. Then we can state that the sine A squared plus B squared equals C squared, right? So sine theta squared, sine squared theta plus cosine squared theta equals, and then we want tangent theta. And in this case, if we were talking about the 90-degree angle and we're talking tangent, it'd be opposite over hypotenuse. Well, if the opposite of 90 is the hypotenuse, anything divided by itself is 1. Okay. Okay, so let me try to explain this differently. So this is what's called a trig identity. And it says the sine squared theta plus cosine squared theta equals 1. And where does that come from? Okay, so here is a right triangle with theta in the corner here, bottom left, angle. Theta is the reference angle, so adjacent is here, which is cosine. So instead of A, B, and C, well, A, B, and C, let's call C R, because we think of that as the radius of a circle. So if this was the center of our circle and we rotate it around, so let me give you an example. Let me get a compass. And I open this up. Of course, it's not long enough, of course. But if I drew a circle around, okay, that would be a circle with a radius of R if this were just out a little bit further. So the length of the hypotenuse is the length of the radius of a circle, okay? So just think of it that way. So then what we do is we say, A is here, B is here, and this is R. Okay, and then I want to call A Y and B X. This is our X axis, and up, down is usually Y, and R would be the radius of that unit circle I was telling you about. So if I ask for sine, I'd say sine of theta equals opposite over hypotenuse, which is Y over R. And if I wanted to solve for Y, I'd multiply both sides by R, so I'd get R sine theta equals Y. And then if I said cosine of theta, well, that would be adjacent, which is X over R, hypotenuse. And to solve for X, I'd multiply both sides by R, and I'd get R times the cosine of theta equals X. Okay. And then tangent is going to be, well, like before I get to tangent. Okay, so since Y is equal to R sine theta, then when I say A squared plus B squared equals C squared, we're actually saying X squared plus Y squared equals R squared. Well, X is right here. So let me start with that. X squared plus Y squared equals, Y squared equals R squared. That is the Pythagorean theorem. X squared plus Y squared equals R squared. Okay, so once I do that, I will substitute in what I have now for my values. Well, X is R cosine theta. So I could say R cosine theta squared plus R sine theta squared equals R squared. So what did I just do? X is R cosine theta, so I substituted in for X and it's still squared. Y is R sine theta, and I substituted that in and it's still squared. And we need to distribute, because this is multiplication here, R times something. So both things need to get squared. So if I distribute this squared, I would get R squared cosine squared theta plus R squared sine squared theta equals R squared. Now there are two terms on the left with both with a factor of R squared in them, and there's an R squared over here. So if I divide both sides, or all three terms I should say, by R squared, let me get rid of this, break that right there, R squared and R squared, then this R squared cancels with this R squared cancels with this R squared, and anything divided by itself is 1. Therefore, we get cosine squared theta plus sine squared theta equals 1. And the order in addition does not matter. So that's the same as sine squared theta plus cosine squared theta equals 1. And that is your first trig identity. Okay, next page brings us to exercises 3 and 4. And it says, in the right triangle with an acute angle measure theta, sine theta is a half. Use the Pythagorean identity, here it is, to determine the value of cosine theta. Okay, so I just showed you where that comes about, and it is sine squared theta plus cosine squared theta equals 1. So that's what we're using. That's what they said to use. So I'm going to write that. Sine squared theta plus cosine squared theta equals 1. Okay, well, we know the sine of theta is a half. So we're going to substitute in the sine of theta. We're going to replace it with a half, and it's squared. So we're going to put 1/2 squared plus cosine squared theta equals 1. Okay, so when I square a half, I get a quarter. So let's simplify this. 1/4 plus cosine squared theta equals 1. And then I'm going to subtract a quarter from both sides, and I get minus a quarter here, minus a quarter here, and we cancel there, and we get cosine squared theta equals 1 minus a quarter is 3/4. Okay, so in order to get cosine theta, we have to take the square root of both sides. So I will take the square root of the left, I will take the square root of the right, and that will lead us to the last step here where we're going to get cosine theta. And it says to determine the value of cosine theta. So we're almost done. So that is going to equal the square root of 3/4, but I don't want to leave that as an irrational denominator. So I want to rationalize the denominator. But wait a second, square root of 4 is rational. The square root of 3. Notice what I did here, by the way. The square root of a fraction can be broken up. So I have the square root of the numerator divided by a square root of the denominator. The square root of 3 divided by the square root of 4, which is 2. So cosine theta is the square root of 3/2 when sine theta is 1/2. That sounds familiar. Maybe a table we did in lesson 29, perhaps. Okay, so let's move along to number 4. Given a right triangle with an acute angle measure of sine theta is 7/9. Use the Pythagorean identity to determine the value of tangent theta. Okay. All right, so we're going to do the Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. Substitute in my 7/9 for sine theta, square it, plus cosine squared theta equals 1. And 49/81 plus cosine squared theta equals 1. And when I subtract 49/81 from both sides, think of this as 81/81. Anything divided by itself is 1. So this is going to be minus 49/81 here, minus 49/81 here. And that will cancel, leaving us with cosine squared theta equals, let's see, 50 to 80 is 30. Plus that 1 to 49, and that one is going to be 32. So that's going to end up being 32/81. All righty. So that is cosine squared theta. So when I take the square root of both sides, I always like doing this in a different color so you see, so I don't have to rewrite the whole thing. That is going to leave us with cosine theta equals the square root of 32 over the square root of 81. So the cosine theta equals, and 32 is 4 square root 2. I remember that from this lesson. 16 times 2, 16 is a perfect square. And the square root of 81 is 9. It did not ask for cosine, it asked for tangent. Okay, but keep in mind now that tangent theta equals sine theta divided by cosine theta. So the tangent of theta is going to be the sine 7/9. And I'm going to use a different color here so you see that it's a compound fraction. And then 4 square root 2/9. Okay, so we're dividing this by this. That's going to be the same as saying the tangent theta of 7/9 times the reciprocal of the denominator, 9 4 square root 2. So the 9's will cancel and we get tangent theta equals 7 over 4 square root 2. And I don't want an irrational denominator, so I multiply both the top and the bottom by the square root of 2. And then we get the tangent of theta is 7 square root 2, and 4 times square root of 2 times the square root of 2 is 2, and 2 times 4 is 8. So the tangent theta, when sine theta is 7/9, is 7 square root 2 over 8. Okay. Okay, this is page 4, the end of lesson 30. Go do your problem set.